Okay, we record all the 3 days of the event because we will use the recording as a proof that this event has been conducted to our funding agency, IKI. Um, well, again, welcome to everybody to this second day of third LTTA of CRIMS project. Yesterday, we had some fruitful discussions about project outcomes. Till now, actually, we are at the last month of our project. So we presented all the work that has been done till now concerning the design, the development, um, evaluation, preparation of training and course material, along with the webinars that have been conducted till now. Today, we will have the last webinar at the afternoon, I think, which will be given by Senkar, along with our partners from the Aristotle University of Thessaloniki and Cognitive UX. Well, yesterday we had, let's say, the theoretical part of this LTTA. Today, mainly we will focus on the material that have been prepared, how we can use it, and also we will present the developed tools, mainly in the afternoon. Our first presentation is about how somebody can use all the training and course material in the knowledge repository of CRIMS. Mrs. Liz Dom from NTNU, we will present us a similar system, a similar online platform, RC, that is used at NTNU in teaching. And she presents us some paradigms how we can use the training material in such a platform. Liz, you can have the floor and start your presentation.
Thank you so much, Dimitris. Must I switch on my camera?
Yeah, of course, of course.
Great. Hello, everybody. Yes, my name is Liz Dom, and I am currently a lecturer at KIT, Kunstakademie Itvarna, which is part of NTNU. And yes, thank you so much for the wonderful introduction. Just to start, I think I would give some, yes, hi, Ao. Ao is also a colleague of mine. Yeah, so I guess just a little bit of a background. So I was a former KIT master student in 2020, graduated in 2022, and this is partly where I was introduced to the research catalog to begin with, because this was COVID times and learning was very much happening online. And so then we were introduced to the research catalog by Alexandra Marie-Leslie, who is also a professor at KIT. And almost immediately, I could see the potential, both as a student, but also as a teacher eventually, as I came to use it. So today, I will introduce you to how we introduce the students to the RC and also how we use it in our courses. So I can just quickly share the screen. Oh, I need permission to share.
You have permission. All I'm going to give you right now. Yes, I think that now you have the permission. Yeah.
Okay, wonderful. Right, you can see.
Yes, of course.
Wonderful. Okay, so I firstly want to introduce you to some of the work I did as a student and how I used it almost as an artistic tool. And so I based this, my research was very much based around the aesthetics of truth, and it coincided with COVID and this idea of people either viewing the pandemic either as this planned conspiratorial thing or, you know, this very much this real event that was yeah, taking the world by storm and having very real life effects. So I made this game basically, and I won't show the whole game, but it's this very rudimentary, almost early internet choose your own adventure game. That based on your ideology, you would either see the pandemic as this normal, unprecedented medical event, or you would see it as this conspiracy. Yeah, based on your ideologies. So this whole research catalog was then centered around information you would typically get online. And then you would be able to read it and then go through the options. So there's lots of opportunities for interactivity. You can play videos, for example, and then as you go through this RC, it may eventually lead you to an outcome. So this was part of my research. I can show you. You can see the second screen now, yeah? Has it moved to the next tab? Yeah. So basically at the end of this, it would give you spit out almost like this BuzzFeed type of quiz result, and then kind of share with people what their ideologies might be. So this was my introduction to the RC, and I used it almost as an artistic vehicle. I also used the RC as a vehicle for my master's thesis in the end. So it was called Tipping Point, COVID-19, Infodemics and Aesthetics in a Post-Truth World. Where once again, you can see there is, at least at KIT, we are able to do, we are able to submit our theses in a more creative way. So we are able to include images and rich media such as videos, stuff like this. So then I was able to submit my thesis also on the research catalog because the research catalog is connected to various education institutions. So yes, this then brings me to, so this is just a snippet of my thesis. And then I can go to how we now use it as a teaching tool. Because I used it extensively, both as an artistic vehicle and then also a writing vehicle, we saw the potential to share this with the students at the school. And this was now when I've transitioned from student to lecturer at the school. So here you can see I've got basically two tutorials. The one is fairly basic and the other one is a little bit more advanced. And then I will show you how we use it in our courses. So this is the basic tutorial. I just give some examples of what people can do. So for example, it has GIF capability, it has image capability, and then you can also just link to various types of content. And so in this tutorial, like I said, it's just the basics. So for example, then I show people how you can set up a table of contents. You can also link. So these are all hyperlinks. So I show people then and students how to do this, how to hyperlink to different pages, how to set up different pages. So for example, perhaps you want a long text intro. Then you would have different options of how to do this. So you can have different paragraph systems, you can have different fonts, you can include imagery in it, and once again, you also have this hyperlinked area where you can always put your table of contents either in the RC or when you go up here, you can always see the contents up here as well. So it has a inbuilt navigation system, and also here it has a, it doesn't show it here. I will show you on another one. It shows the navigation on the page because it can get quite large. So then here I can show you number 3. It goes to an iframe. This is also something that I wanted to show the students. Oh, almost done. So you can include iframes. This is content that lives outside of the RC and you can bring it into the RC. So as you can see here, it has the research catalog's URL, but it links to something on NTNU Open, for example. Then it also has the capability for rich media once again. So here we can pull in, so this was some visual research that we did. It was a music video made in relation to this paper, performing meat replacement as drag. So we made a music video. We are able to pull in the music video and then you can play it alongside this content. I can also show you our more advanced tutorial that we use. I don't have much time. So this is more advanced tutorial. Here I just show students what you can do with text, for example. So you can use different colors, you can use different fonts. Again, you can use rich media in the background. And then we want them to test it out. So this is what we then do. We create a tryout page where they can just go wild. So here they would do all of their experiments, for example. And I think the RC is a really great tool for this HTML integration because you can basically code or program virtually anything into this research catalog, including live streams, which is something we are now also experimenting with at Git. So here we also have an audio tryout page. This is also something really nice that the RC can do. Sorry, can you hear the audio?
No, we can't hear it.
You can't hear it. Okay. Well, I'm supposed to, I'm not sure how to share my audio from the computer. Let's see. Well, I can share this link with you afterwards, then you can hear the sound. So basically, there is a fire crackling at the moment, and it kind of sets the tone for this visual that you're seeing, and it's kind of like a story. So it's a beautiful cloudless evening, you're warming yourself by a campfire that you just got going. So if you click on this moon in the RC, the link that I will send you, it plays the sound of a wolf howling. And then you see a lantern in the distance, and then if you click this lantern, it makes this person laughing or cackling sound. So this is another way that you can integrate audio into almost storytelling type narrative into the RC. But here then we ask people to also experiment with us and try out these things so that they can learn how to do this, because you can, this is basically coded. And then just the last page on this more advanced one. Again, the rich media part of it, you can integrate videos from YouTube in this almost way that it looks part of the landscape. So here we have a wolf howling. It's just a video from YouTube. Again, you can't hear the sound now, but the wolf is howling, and you can integrate maybe some information about what you are seeing. So that is that tutorial. Demetrius, how much time do I have left?
You have more than 20 minutes. You have plenty of time.
Oh, okay. Okay, great. I thought I heard a bell, so I thought maybe my time was running out. Okay, so then, okay, now I can calmly show you the rest. Then I can show you how we do use it in our courses. So in 2023, we used it as part of the electronic media course. This was our first tryout to use it with a course. So basically what we did is that we put the course description and syllabus online, learning outcomes, etc., and also what the students will be doing each week. And then just have some rich media. So we use this section both as a course outline, but also a working space. I'll just move this widget. So we use this as the working space. So here we listed some resources that people could use. So either books or resources that they can get in the library, or for example, it links to a PDF. So here, for example, is the PDF. You can just click on it and it opens up in a separate window. And that is always very nice. Yeah, so this was a scanned PDF that we just wanted the students to read, and then we can link it to that, for example. So here we have the resources. As part of this course also, we wanted a live streaming element, but we did not use it in this course yet. We will use it in the next one, which is starting today. However, we also listed some music videos, examples using different artistic approaches. So once again, it was brilliant that YouTube could be integrated into this platform. So we just gave these examples for students to have a look at. What could they do aesthetically, visually, musically, all of this. Then they also created their own tracks to use in the music videos. So we then, as the course developed, we started just putting it back inside the research catalog. So we were almost building the knowledge and the artistic creation as we were going along. So once again, you won't be able to hear sound, but if we click on this would essentially play the beats that they created. Then just more music videos. And then in the end, we also have a section for the student music videos, so what they actually did. I will show you, so they were in 3 groups, and I will show you this last music video at the end. So this was our working space, and then the students also set up their own. So this is the research catalog of the last student group you just saw. So as you can see, they have their own aesthetic. We did not guide them at all. They were purely using this as they would normally do. So here they put a bunch of music videos as inspiration. First of all, much like what I just showed you. Then to create their music videos, they assembled some mood boards. So these were for characters that they were imagining that could go inside the music videos. So this was very nice. They collected some images for their characters, how they would appear in the music video. So this was almost like a brainstorming page. So here they also include props. They have some practical ideas for movement that they wanted to use. They had some practical ideas for reflection, how this would appear in the music video. And then also just some general aesthetics that they wanted to include. Again, some movement experiments that they were looking after. And as you can see, you can move quite interestingly, like around these pages. Then the final part of their research catalog was to document everything that they've done so far. So this was all of the music that they created, and they were placing it as they were making it. And then the final draft was posted here. They also had some very practical information on how they wanted to shoot the music video. So things like lighting, camera movement, framing, etc. They also did some movement exercises. So here combining the analog with the digital. So they have physical sketches, which they then brought into the research catalog. Again, just some movement experimentations. This was also from some of their experimentations that they then put in here. So this is a part of the music video. So they were testing out, for example, these reflections. This was just a reflective rain jacket, but they were testing it in different lighting conditions. So very much using it as a brainstorm platform, but also ongoing, like building on their visual research, if I can put it that way. Which then led to, I can show you here, just a bit of this music video. Once again, you'll hear the sound when I share it. but it then resulted in this music video that they created. Just a bit of that. And then I think last but not least, I can show you what we are working on now. So this is a new course. It is called On Display, Process and Production. And it is centered around what is creatively called the kitchen TV party. And so what basically will happen is that this course will introduce students to the act of gathering, the act of sharing, knowledge building beyond cultures, and then also create this live streaming cooking, performative cooking show at the end. So here again, we have the course outline in the beginning, just some information. So this is not completely finished because this is something that we want the students to build on with us as well. So this is just a landing page for information for them. So they will be in rotation. There's different groups, a cooking group, a stream art group, and also a live research group. The live research group, for example, will be contributing to this research catalog as they go along in the course. So the thing that I just showed you from the previous course, this was our almost like pilot or trial run of this. And so we want to take this even further and make it more rigorous as far as online research and knowledge building goes. Then we have our teachers over here, just telling everybody who they are. And then over here, we have this section where so over here from tomorrow, this will be replaced with a live streaming link. So basically they will be cooking and they will be in conversation with an Afghani. He is the owner of one of the stores in Trondheim, grocery stores, and he will also be teaching them how to make certain recipes. And this will be live streamed both from this grocery store and also from a professor's kitchen into the video lab at KIT and then back into the research catalog. So what you see here will then always be live and you can always tune in whenever the course is on to what is going on there. And it will be, it will culminate in a live cooking show where all of these things are brought together as a research package, which will then also be live streamed here. And then last but not least, this is their note-taking page. They can put all of their notes here, and this research catalog will just be built out even more as we go along. Yes, in a nutshell, that is about it. I would say for the most part, we use the research catalog as a learning and research tool, and then secondarily for those who want to, and I see more and more people at the university wanting to do this, using it more as a exhibition format or artistic medium. So this is a way that the research catalog has been used in a more innovative way, I think, than has been used before. And yeah, you can have a look at what's on the research catalog. There's many people also contributing to it continuously and doing amazing things.
Well, thank you very much, Liz. It was a very interesting presentation. You gave us a lot of ideas of how we can exploit the knowledge repository we have created till now in our project in an innovative way, let's say, for training our users. Maybe we can discuss some issues here. If is anybody that wants to ask a question to Liz to start a discussion about that? First of all, Liz, have you read the material we have uploaded in our knowledge repository? I'm talking about
Yes,
the CRIMS project. What is
yes,
your
yes.
feeling about this material? How do you feel we can exploit it? Can you give us some directions?
Yes, absolutely. Well, I mean, in terms of these materials, I think for sure something like the research catalog, or at least like some kind of platform that has a more dynamic approach, I think is the way to go forward with, relaying this information, getting people on board and helping them retain it in a better way. Um, so yeah, if there are many directions that it could potentially go, I'm also, for example, trained as a content creator, so I'm always thinking of, different ways to relay content. So uh, as you can see, we've experimented both with video content, which is very popular these days, as well as this live streaming component. I think for the most part, I think the more dynamic this kind of material can be, the better, because people's attention spans are very limited these days and they don't have much time. So the the faster and the more almost compressed we can relay this knowledge, I think the better.
Thank you very much. Uh, are there any other question for Liz? Yes,
Um,
Adele. Yeah, yeah. Good
yeah,
morning.
not necessarily a question, but just a couple of observations from my vantage point, having seen a bit into the CRIMS project and also having seen how we use Research Catalog at KIT. Um, Research Catalog it has a bit of a learning curve and is a little bit counterintuitive for most people coming from other tools. So people tend to struggle with it initially. But once you get used to it, it reveals the versatility that it has, and people tend to now find quite a lot of agency to do quite a lot with it. I've been quite impressed in the teaching, the way it's being used for teaching, which you presented. I've seen Annette use it for the same purpose, but seeing the examples that you presented, Liz, um, as like sparked up ideas in my mind and further reinforced the idea that research catalog can be so versatile. And I think part of what makes it strong in what it does is the fact that it has different modes of presenting content. You have the infinite canvas mode, which is a more graphical kind of layout, and you can go as far as you want and spread out your content in whichever way in that 2D infinite canvas space. And then you have the block mode, which is more like text based, but fit in a formatted kind of way. And you can also work with HTML. You can work with long form text, and you can mix media in different ways. So it gives people lots of options for presenting content, which I also see Creams as trying to do in terms of using different types of ways of using 3D media, whether with AR or mixed reality, and then in the typical VR enclosed space for presenting content. So I see the Cringe platform as maybe having similar challenges to what Research Catalog might present to new users. But I'm also now thinking that maybe Cringe could also um, look at Research Catalog as being in a bit more advanced stage in terms of having users on board and who are using it and who are bringing in their criticisms and seeing how it has managed to thrive despite its challenging sides to its usage. And through that, now figure out how Creams can consolidate on its own strengths. One other possibility I see is interlinking both. Like the live streaming that Liz presented shows that there are lots of possibilities, there are lots of ways in which you could use Research Catalog. So if it was possible to interlink and embed content from Research Catalog in Creams, for example, then that immediately expands the possibilities within Creams. So it means you can do 2D type of content in Research Catalog and automatically just import that into a 3D environment in Creams. And maybe vice versa. You might have a project that you want to present in both ways, in 2D and in 3D, and you build a version in 3D that is in Creams, and you build a version of some part of the project that is 2D in Research Catalog, and then you interlink both. You have links that drop you from one world into the other. I see such possibilities. And one of the challenges we had at KITS is the fact that many of the students are more used to platforms like Research Catalog or Research Catalog specifically because they use it for their curriculum. Then when they now go to a 3D platform, what comes to their mind immediately is stuff like Roblox, is like the gaming kind of mechanics. That's what they're expecting. And then they now meet something a little bit different. So they struggle to like accept that format or accept that way of interacting with art or presenting their art. Maybe media students might approach it differently because they immediately have a different kind of perspective to how they handle affordances in digital space, in 3D space. Yeah, so those are just a few of the observations I thought to mention based on my prior engagement with Creams and my knowledge of what it is like interfacing with Research Catalog as well.
Yeah, wonderful. Actually, I had the same thoughts when I watched Lee's presentation, how we can interlink the two environments. Maybe we can use RC to build a course, having as materials tools or outcomes of creams. For example, I saw the functionality of live streaming. Maybe there we can put an exhibition authored by a student. Or in a previous section, we could say some things how you can create your own exhibition environment, allocate artworks digitized in this environment, and after that, as a link, the student himself can give a tutorial to other students. I think this is actually a challenge. Yes, yes. The, the linkage of these two environments. Yes, yes, it's a challenge. I'd like to see something like that. Maybe it's a challenge for any new partner. Try to build a course based on CRIMS tools using RC. It would be very interesting. Yes, Liz.
Absolutely. Yes, absolutely. I agree with both you and Arielle. Something that I just wanted to add in terms of maybe younger students and kind of their expectations. So I think they're more used to sort of like a drag and drop environment where everything is kind of easy, intuitive, and this is more of this old school early internet environment. However, I think the power that the RC provides is this the ability to code anything. So if you are at all HTML proficient, even in a basic way, you can do amazing things. But if you are, say, a professional coder, which is something that potentially this could also be combined when we are thinking about something like a course that teaches, you know, how to use these tools, is to bring in this coding aspect, because I think perhaps the students are not even aware of what they could be doing if they were just exposed to the code to do it. So yes, that's just an extra layer that I wanted to bring in there.
Yes, I'd like to bring into this discussion Marios. Marios is the developer of Cream's platform. Maybe he has seen some, let's say, challenges in this incorporation. Marie, can you say something about that?
Yes, hello everyone.
Hello.
I heard the discussion was very interesting discussion, very nice presentation, Liz. Yeah, well, the main challenge between interlinking the two systems relies on the technologies that each system is built on, and we need to see, for example, from our side, we have built a technology where we rely a lot on an application programming interface, so we expose all our endpoints at the server side so that various client applications can request and receive information from our platform. So it would be interesting to see that maybe there is documentation of the research catalog as well to see how these two systems can communicate with each other, to see how we can integrate things. But I assume is there any, I had a question, I was thinking, is there any online documentation about the system, about maybe there is an API in RC where we can look into things?
Yeah, absolutely. I can link you to this section on the RC's website, and also I can put you in touch with a developer because that has been very useful for us. For example, is that as we were working with it, we ran into some challenges. For example, we wanted to be able to see if people, like almost like a Google document, when several people are on the document and when they are editing things, we want to see who changed something last. We wanted a chat functionality so that if multiple people are working on the same RC, that you could talk to each other in real time about the project that you were working on. And because at the time, the research catalog was still very much in development, the developers actually took on our suggestions also. So that was really integral to help develop the platform, but also, yeah, just this like ongoing upgrade and fine tuning of the platform. So I'll put you in contact with this developer.
Yeah, that would be nice. And our
all
the technologies will be open source after the end of the project, which is ending right now. And we have also an online documentation, an interactive API where we can a programmer, student or developer in general, someone who is coding, can test real time the various endpoints of the API. And so yeah, we can further explore that.
Actually, I'm thinking that RC could bring Cream's repository to life. Maybe it's a way to see the practical point of teaching, because it is a 2D environment actually, and it is common to a student to use 2D like environment. So let's say it's a smooth step towards the usage of a 3D educational environment. But this is interesting.
Yeah, I agree.
Maybe at this point we can bring to our discussion Aristotle University. I think that Dr. Skodras and Mrs. Kalidi are with us. Maybe they can make a comment about if it is interesting to see an evaluation of such interlinked environment using RC and CRIMS together. Maybe it is interesting and challenging if you think in evaluation of such an environment. What are you feeling, Alexandre?
Hello.
Hello.
I think that's a very interesting situation. I think that they can be interlinked, as I saw. Of course, based on the presentation, I mean, I have this information. So based on the information that I saw, I think that it can be interlinked. Now we're also in the stage that CRIMS is in the last stage of preparation. So the actual digital technologies are almost in the finish line. So I would say that first of all, at the level of sustainability of the project, many like if the project can be used as a, let's say, as an example, or can be like also other stakeholders can use it to see if they can implement it or tailor it also to their needs into other situations. So I think that based on that, it can be a fruitful idea, like if other projects or other digital scenarios or other educational scenarios, it's something that it can be used. I think that it's a good idea, and also understand like the interpolation of, because also NTNU, it's even though not at a it's not a digital tech provider, but a provider of knowledge and a provider of the schemes of studies. I think that they can use it. Of course, this is also the requirements of the project to their need in the following months or years. It's something that it can for sure be an added value to everyone's department or is my
Thank you, Alex. Well, is there any other comment, question, anything? It was a very interesting presentation, Liz, and you raised a lot of challenges in our minds. I think it was a good chance for us.
I'll just like to
Yeah,
add
yeah, I can tell.
for Marius's benefit, and to reinforce what Liz said, you might not readily find documentation at a very low level for development for RC. However, the developers are very helpful and very ready to offer help or or support to anyone wanting to do anything without you. So I think that would be the way to go in terms of trying to experiment with integrating in any way. And if anything happens in that direction, I'll be very happy to also contribute in any way to that kind of integration, as I'm sure Liz also would be, especially because at KIT, there's already a lot of push towards getting people to adopt research catalog, and a lot of people already use it. So if we are now talking about CRIMS within the context of something happening in research catalog, then it's easier to onboard people to try something new with CRIMS.
Is there another question? Okay, let's thank our presenter. And now we have our coffee break, and we will come at 12 o'clock for the next presentation. Thank you very much.
Thank you.
Thank you.
Bye-bye. Nice to meet you.
Nice to meet you. Bye.
Hello, Dimitris. I couldn't hear you. Sorry. Could you please repeat?
Yes, yes.
Okay, now I hear you. Good. How are you?
Okay, okay. Well, you have the floor to present us the work that we have done concerning the development of CRIMS tools.
Sure. Thank you. Is the recording on cloud okay? Because
I think so. I think so. Yeah.
Okay, so hi everyone. I'm Argyris Konstantinidis. I represent Cognitive UX GmbH, which is a partner responsible for the technology and development. And in this session, we will start first with Ifigenia Skalili from Aristotle University of Thessaloniki, where she will present us with the augmented reality mobile application. So Ifigenia, could you please start, and then I will take over to demonstrate the different technologies that were implemented as part of the CRIMS platform.
Yes, hello.
Hello.
Hello, Evgenia.
Hello. Let me give me a second to share my screen. Does everyone see my presentation?
Yes.
Great. So, hello, I'm Iphigenia Scarlidi. I am a member of the Laboratory of Geoinformatics from the Aristotle University of Thessaloniki, and I will present to you today some tips and tricks on how to implement your own AR mobile app application, like we did in the context of CREAMS. So, the application was implemented inside the project result PR2. The lead is Cognitive UX, and the participating partners is Panepistimiou Patron, TEC, Aristotle University of Thessaloniki, Senkar, and NTNU. Sorry. The developed smartphone application, which we created, enables visitors to interact with the students' artifacts in the context of physical exhibitions. The final version allows for the user to augment the selected artifacts. The augmentations can occur either in a physical outdoor space based on geolocation services, within indoor exhibitions by scanning a QR code, or in-home by augmenting any artifact in the viewer's physical space. I want to start with these slides because we will dive into this later and give you a little context. This is the more technical presentation, and let's get right into it. Why we chose Android Studio to create this application? It has official support from Google. Android Studio provides the most up-to-date tools, features, and APIs. It has very good building tools like a layout editor, logcat emulator profiler. It enables integration of ARCore and maps. It has a very excellent debugging system with breakpoints and real-time variable inspections, and also the Gradle build system. It simplifies project configuration and dependency management. Also, why Kotlin? Kotlin became Google's preferred language for Android development in 2019, replacing Java as the default. It requires less boilerplate code compared to Java. It has excellent null safety, and it reduces thus app crashes caused by null pointer exception. It is fully interoperable with Java, allowing developers to use existing Java libraries and code bases. It has coroutines for asynchronous programming. It has also official Google support with Jetpack libraries like ViewModel, LiveData, etc. And they are designed with Kotlin in mind. It also generates bytecode that is as efficient as Java, ensuring performance isn't compromised. Finally, it has a growing developer community offering extensive resources, tutorials, and libraries. And although we will just scratch the surface with this presentation, you can also log in, check whatever happens. It has very, very good, a very, very vibrant community, and a lot of people are programming mobile applications with Kotlin. So let's dive right into it. Let's set up the Android Studio. Before, you have to make sure to download the executable, install it, follow all the instructions, and make sure that the SDK platforms are installed. We wanted to target Android versions of an API level 26 and more. It's the Android 8.0 Oreo. So you need to download the appropriate SDK managers, and along with it, there are tools. It needs a little bit of RAM, and it also requires quite a bit of memory. So make sure that you check whatever is up to your needs and to what app you want to create. You also can install an emulator. It's optional if you want to use to test your application directly with your phone. It's okay, but also emulators provide faster debugs, and it's a very nice safety option. To set up the project, you need to add necessary dependencies. Like before I showed you the first presentation, we used Google Maps. So we need Google Maps SDK. We need Play services because that's where it will download Google Maps. We need AirCore because we will augment some artifacts. And all of these should be declared and added as dependencies in the Gradle dependency management. You also should enable permissions in manifest. It's a file that checks if you have the permissions for Wi-Fi, to use the Wi-Fi of your phone, to use the location of your phone, to use the camera in your phone. All of these should be added in the manifest file of the app. Regarding maps and location integration, this is a very vital step if you want to, necessary actually, if you want to create an app with a Google Maps in mind. And it needs to you need to create an account in a Google Cloud platform, and you need to generate an API key in order for you to use your Google Maps in the testing and in Android Studio in your app. And you also should check for runtime permissions before accessing the user's locations. Regarding the UI UX development, we found that the Android Studio provides an excellent responsiveness using constrained layout and scroll view, because you can make layouts adaptable with for all screen sizes. You should always keep in mind that not all screens are the same, and we will dive into it later. And enable auto-size text type and text views to ensure proper scaling across all devices. Also, it's vital to enable map features like zoom controls and gesture handling when you want to create an app with a map like we did. The AR core, which I mentioned earlier, is used for the 3D models. It integrates AR core to display 3D GLB files for interactive experience, and it ensures that it is compatible by checking AR core support. We also used GLB files. We wanted to use GLB because it's faster to load, it's smaller in size, and it also requires less files to augment. It is only one file in binary. We used compressed GLB files to reduce app size thus and improve loading performance. And we also validated models in the Cineform viewer before we integrated them inside the application. Also, we used separate logic for 2D and 3D artifacts, and we differentiated them using metadata. Now, according to data handling, this is some basic programming knowledge. You should always serialize data for intent transfer. And how we do this, we use something called parsable and serializable, which is an efficient way to pass data between Android components, such as activities and fragments, or for storing data in bundle offsets when we want to pass those along different activities. It is very optimized, and it has a great performance for Android platforms. And also, you should avoid hard-coded URLs. We use store-based URLs in centralized constant files. And regarding the images, we use libraries like Glide and Picasso to load images effectively. Another great option that the Android Studio has is the debugging and logging. As you can see from the screen, it has a very good, let's say, screen below the development area, where we can see whatever we have implemented inside our code as error messages for debug. We use meaningful log statements to extract execution flows, like fetching user location within maps activity, etc. We also enable strict mode in debug builds. We thus help detect performance issues and bad practices. It allows us to catch accidental disk or network access in the application where UI operations are received and animations take place. Regarding performance optimization, we use location requests to set intervals for location updates to avoid unnecessary battery drain. We don't ask to check the location non-stop. We have some steps, and we save battery thus. We recycle map markers and we remove the old ones before adding new ones. And we also compress the assets by using tools to compress the images or optimize the 3D models. We will augment later within the app. And as I mentioned before, the emulator, if you want to test without a phone, is great. It is on the right side of the screen in the Android Studio. It offers test location-based and AR features on a physical device, but within the Android Studio. And you should always, of course, check and not finalize your application without prior checking with a real device. We also tested with different screen sizes. It's very good to do that because you can catch lots of errors. You must ensure that the UI consistency is across devices using Android Studio Layout Inspector and preview tools. And also we added some mock locations for testing purposes, like simulate GPS coordinates and feeding mock data, in development mode. Finally, some common pitfalls to avoid. Those are, as I said before, some very common tips. You should enable ProGuard for security, which hides the code and making it a little bit harder for attackers. You should always restrict your API key, which you implemented and you generated from the Google Cloud Studio, because many unauthorized domains might try, or apps might try to use it. And you should integrate tools to monitor the performance of your app and identify bottlenecks and stuff post-deployment of the application. Some other pitfalls you need to avoid is hardcode permissions. Of course, always check and request runtime permissions dynamically. You should ensure that AR core features gracefully handle unsupported devices with fallbacks. Shout out to Cognitive UX for helping us test this. And also use scroll view to make apps scrollable on smaller screens. And finally, you should always check for null values, especially when receiving data from intent or any external APIs. I'm sorry for all the tech words. I hope you understood my presentation, and thank you for your time.
Thank you very much, Fiona. It was really informing. Now we will carry on with my presentation. Let me just share my screen. Okay. So let me just put that on the side. Okay. So in my presentation, we will go through the different technologies and the architecture that the CRIMS platform is built on. First of all, I'll start with the focus of the session, which is about learning the different technologies and tools that were used as part of the development activities, and as well as familiarize with the code base and learn how someone can design and build a client-server architecture like the one that we built as part of the CRIMS project. Also, at the end, I'll go through basic files of the code base that allows us to easily modify the code or make some adjustments or extensions based on the open source solution that will be provided. So at first step, I'd like to guide you through the high-level architecture design. On the left side, we have on the left side of the slide, we have the different client applications that are part of the client-server architecture, and that includes the digitizer mobile application, the Art Center content management system, and the different virtual reality, mixed reality, and the virtual exhibition that can be presented on the web and on the AR application and the mixed reality application too. On the right side, we have the server architecture that is responsible for serving the requests that arrive from the client applications and for hosting the data, the artwork, the exhibitions, and all the information related to the project. Now, I will guide you through the architecture style that we use for the software development. The backend of the system is implemented as a web server API, where API in the world of software development refers to application programming interface, and basically includes a set of rules that allows different types of software to communicate with each other and exchange data. In the context of the web now application, there is the architectural style of the REST, or representational state transfer application programming interfaces, that includes the rules and protocols for building and interacting with web services. And this API, the REST API, is based on the HTTP methods and allows for creation, retrieval, updating, and removal of resources on a server. Why we chose this type of programming interfaces? In general, using APIs allows us to have multiple client applications that can communicate and send and receive data and resources to a centralized service and a centralized database. Also, it enables the user interface to interact with other data sources or services, as well as for complex processing. In cases where there is a need to support machine learning or artificial intelligence services, APIs are always suitable for consideration as the implementation to integrate such kind of machine learning or artificial intelligence services. Moving on, it allows for scalability of a system and is really effective during the development process. Moving on, I'll present the overall backend architecture. Again, on the left side, we have the different types of client applications that were implemented, including the web application that is responsible for the content management and the VR exhibition, as well as we have the two mobile applications, one for the augmented reality exhibition and the other one for the digitization process. And finally, there is another client application that demonstrates mixed reality exhibition in a Microsoft HoloLens application. So these client applications interact through web APIs with the backend. On the backend, the implementation includes a server-side web application programming interface and different types of tools and technologies that serve a specific purpose in order to have a working and efficient solution. So I will here outline the technologies, and in the next slides, we will go into a bit more details about the purpose of each one. So first of all, the platform and the backend is implemented in Python programming language in using the Django REST framework, which is one of the best toolkits to use when you would like to implement such a server-side architecture. Also, for deployment purposes in front of the entire server, we add an additional layer of security and handling of the incoming and outgoing requests, for which we use Nginx, which in our purpose acts as a web server and can act also as a load balancer or as a reverse proxy. Next, we also use GUnicore, which is an application server now that implements the web server gateway interface that is responsible, as we will see, for translating the incoming web traffic into something that Python can understand. Also, we have used Celery, which is an asynchronous task queue that relies on distributed message passing. And for the message broker, we use RabbitMQ. For the data storage, we utilize a relational database management system, which is called PostgreSQL. And the whole solution runs inside Docker platform, which is a technology that allows us to build everything, including the dependencies and libraries needed for the code to run, and so on. And this runs as part of the as a process in the operating system compared to virtual machines, as we will see, and it makes it really lightweight and efficient. Now, a few more details on each of the technologies. So the server-side web API is the programmatic interface, if you want, that consists of the different endpoints that are responsible to implement some functionalities. And there is the concept of request and response message system. And this is expressed in JSON format and is exposed via the web as HTTP request and response. With regards to how we build the APIs, as I said earlier, we use Django REST framework, which is the toolkit that includes all the underlying mechanisms that are needed to build web APIs. For Nginx, this is used only in the live system that is currently live and is used as a production system, if you wish, which acts as the web server that sits in front of the server-side web API. And through GUnicore, which implements the web server gateway interface, the incoming traffic is being translated into code and types that Python language can understand. Next, we have Celery. The reason we use Celery, this asynchronous task queue that relies on distributed message passing, is because we wanted to support some heavy or time-consuming tasks. And for this kind of tasks, we have to be able to respond back to the user or the client application as fast as possible and avoid blocking other incoming requests. So if a task is really time-consuming, it can create delays, and it adds limits to how many pages or requests the platform can serve at any given time. So the idea here is that for tasks that we know in advance that will be time consuming, we can first, instead of try to execute them directly, we pass them in a queue, and this queue will be responsible to put it in line and have it executed. And when the execution finishes, we will get back the result. So with that, we avoid blocking other incoming requests, and we are able to respond to many requests at any given time. But this asynchronous task queue relies on a message broker. So for that purpose, again, we use RabbitMQ, which is an open source message broker that implements not only the advanced message queue protocol, it has been extended with additional protocols, but it works quite well with Celery. And the reason is that Celery is relying on message passing, so to the queue back and forth. So we had to have a message broker that sends and receives message to and from the queue. For the storage of data, including the different types of data supported in the system, as well as like information about user accounts or activities or artworks, exhibitions, and so on, we had to have a database. So for that, we use the relational database, PostgreSQL. And all these different technologies, including the code itself, the source code, are being built and run inside Docker technology, which allows the creation of containers that contain both the code and all the underlying libraries or additional files or resources that will be required in order to have the solution running. Now, I will give you a few more information about Docker, as it was also indicated in the platform. The idea of Docker is to help developers to build, share, and run container applications. And they claim that they handle the tedious setup so developers can focus on the code. And some of the benefits of utilizing Docker technology to run the solution on a live system is that it allows for portability of the solution. So if I have the Docker engine that is responsible for running and maintaining the Docker containers on a machine, and then if I have, again, the Docker engine on some other machine, then I expect that the code will be portable because I don't rely on the operating system or the specific libraries that were installed, or they had conflicts sometimes and so on. This is not the case with Docker because, as I will show you in a while, we define what we need in some configuration files, what versions of libraries we need, what resources we will use, or more advanced configuration, like what will happen if the container runs out of memory, for example, and so on. So all these will run exactly the same. So whatever libraries we have in my machine, we will have the same exact libraries if I run it on a live system. So I don't have any dependencies on the machine, but I rely on Docker to handle everything. Another benefit is that it's very lightweight and it makes efficient use of the operating system resources. So the idea of Docker is that it allows us to first package and then build and run our application in isolated environments. So all the dependencies are bundled inside the container, and then they can run across different computing environments. It has some similarities to the virtual machines, but instead of utilizing and requiring a lot of memory and space, these containers run as part of the operating system as normal processes in the operating systems. On the other hand, VMs are fully isolated and they are heavier and take more time to load. But in the case of Docker, this is lightweight and it can start and have it running way faster compared to virtual machines. So what someone will need in order to be able to build and run the entire Screens backend architecture, first of all, they will need to download Docker Desktop. This is the official application, the technology of Docker, which offers the Docker engine, and then they can start experimenting quite very easily because it's only a matter of 2 commands I will show in a while to get things up and running, and also extend the existing software if they wish. So if someone wants to download Docker, here's the link as well. And the other thing, this is not entirely mandatory, but in terms of local development, it's way easier to use command line tools. So in order to get the code base of Screens, which is hosted on GitHub, someone would need to clone the repository first and then bring everything locally and then start running it. So for that, there is the Git Bash software that offers an emulation layer for Git commands, and someone can download it from this link. And then it's a matter of, again, running a few commands on the terminal to get the code and start experimenting with it. Now, a few more words about the Django framework that we used for building the web APIs. This is an extension of the Django Python web framework and offers a lot of different components that help with the creation of the APIs. Some key features that are being offered as part of Django REST Framework Toolkit include serializations that occur by implementing the correct way of having serializers, which in essence, they help us convert different data types to JSON or other formats. And this helps with sending data across network or for validation of any incoming data. Validation is always something that we should be taking into consideration. Other than that, we have the concept of views. The views are basically the logic of the application. So each API, as I will show you, is responsible for a specific purpose. There is this implementation that needs to be part of the views. And also there is the URL routing. So each URL that we hit or we call from a client application, either a browser or a mobile application or any other client application, needs to be mapped to a specific view that will execute the request and return some response back to the requester. Other components that are very powerful inside Django REST framework include authentication and authorization. There are built-in authentication mechanisms like tokens or sessions or JSON Web Token. It supports all the core authentication methods, and it allows us also to either implement our own authentication method by inheriting from one of these, or extend in case we would like to add some additional information to our tokens. There is also the possibility of creating a custom authentication or authorization method. Another cool feature that is being provided as part of the REST framework, it allows us to create a specific URL that serves as a web interactive API interface, which allows the developers or third-party applications that want to interact, or either a client application, for example, they can, once they have the correct authentication, they can also interact via the web browser with the API. And one such example, as we will see in a while, is Swagger, that implements the Open API specification. And this brings all the APIs on the browser, and we can directly interact with the server from the browser. And in general, it offers a lot of handy functionalities for dealing with datasets like filtering, ordering, or traversing datasets, and so on. So here is a screenshot of the interactive API that we will see in a while. And from here, from within the browser, we can interact with an API. Also, we can expose the documentation of each API, which helps developers with their implementation, because with this documentation, it's easy for someone to understand what types of parameters are expected for each API, what types of responses are expected based on different scenarios. So if things worked well, there is a specific status code that is returned, for example, HTTP 200, along with some information, or if something went wrong, either in terms of validation or in terms of permission, for example, or in terms of unexpected errors, then the requester will know the exact type of either success or problem that occurred, and they can act accordingly at application level and decide what to do in each case. So finally, a few words about the client application technologies and their development environment. As part of the CRIMS platform, there is also the virtual reality editor and viewer, which is implemented using the A-Frame web framework, which is an open source framework that allows developers to build virtual reality experiences on the web. The augmented reality application, as already indicated by Fiona, was developed using Android Studio. There is also the mixed reality client application, which runs on Microsoft HoloLens Generation 1 devices, and it was implemented using the Unity engine in C#. And finally, the other Android application that is responsible for the digitization, again, it was implemented using Android Studio. Now, the latest knowledge and technologies used can be found on the project's website through scanning this QR code or by visiting creams-project.eu. And that's pretty much it in terms of the presentation. And for the remaining of the time, I will go through, first of all, the code and explain a few things about the REST framework that we used. And then we can run the code locally to see how easy it is to get things up and running in a local development environment. So now I'll quickly switch to the code that we have. Let me just, okay. So as I said in the presentation, all these are the different files that comprise the web server API. There are also HTML files along with CSS and JavaScript for the web pages that are available as part of the platform, as well as all the views that implement the application logic for each API. Before we get there, since the entire code had to be part of a Docker related, for that we had to create some configuration files, and one file is the Docker file, which in this file we specify the base image from which we will inherit. In that case, it was Python version 3.10. And from here, we can also update the packages that are part of this image and add some files, for example, the requirements.txt file, which includes all our Python libraries that are needed in order to have the server running. So here we can add some specific commands that relate to the code and the environment, including the libraries. So in the requirements.txt file, you can find all the different Python modules and libraries that are needed, along with their pinned version at the time of developing. Now, the Docker file will be responsible for taking the installing first the Python language in order for our code to run, installing any dependencies based on the libraries that we will need, as well as adding the code base inside the container. So once we have the programming language, the code, and the dependencies, the libraries, then we can use the YAML files that are responsible to run the container. So in these Docker Compose YAML files, the one is for local development and the dash production is for the live server. In here, we can define what services and how many containers we want. So for local development, we definitely need the database. We need the development server. We need RabbitMQ and Celery, the asynchronous task queue, along with the message broker. So each of these services will be created as containers within the same network. But in the case of the live system, in the production environment, we also had to have in front an Nginx container, which acts as the web server and is also pointing to the correct domain name that is used for the Creams platform that is currently live. So that's with the configuration. And in terms of URL routing, as I said, the Django REST framework allows us to define what happens when a specific endpoint is being called from a client application, either a browser or a mobile application. So in here, we have to define all the paths that are available in the system. So for example, in this block of URL, all these endpoints refer to the management of accounts. And here you can see the URL that corresponds to each of these endpoints. So we have one for account activation, for creation of user, for logging in, logging out, for requesting verification codes, password reset codes, updating password, and so on. So let's take the first example here. So this is the URL that will be called from a client application. And here we said that each URL must be mapped to the application logic. So from here, we will end up in the implementation of this particular URL. So these implementations are part of the views account file. So let's search for the first one in the views account. So that's the API implementation that is responsible when someone calls the activate account. In here, we set the serializer. We said what types of response someone will expect. And we define that this is a post HTTP method. And then this code here is the code responsible, is the implementation of the logic. And here we see what happens if the account activation, for example, is correct, or if it's not correct, or what will happen on the database that will set that if it's correct, then the account will be updated to activated, and then the user will be able to log in. Otherwise, an error message will be returned. And this is the case for all the APIs that were implemented as part of the project. We have account management, artworks, exhibitions, assignment, teacher, pages, artist, teacher, again, admin, student. All these are part of the implementation, and each one maps to a specific implementation on the backend. Another thing that I wanted to show you is how we can build and run it locally once we have the code base. So in here, this is my local version of the Cream server. I have locally the latest code. So if we check here, we will see the same files that we saw on Visual Studio Code. And since we are in a local environment, I will use a Docker Compose YAML that doesn't contain the Nginx. So what someone has to do first is they need to run a command using the default development file and build it. So as I pre-built everything yesterday, this build it will be fairly very quick because it will use the cached layer that I have locally. But if you build it in the first time, or if you use the --no cache flag, it will rebuild everything from scratch. And this might take a few minutes because it needs to download a lot of packages, and some packages are quite heavy. So that's for building. And then once we have built the image, we can just run the command either with this -f configuration file or without it, because it's a default and it will pick it up. And this now will generate the services that we saw on the Docker file. So on the Docker Compose file. So these services now, the Postgres service, the development server, RabbitMQ, and Celery will be generated here. And we see that they are all four running and they can interact with each other because they are part of the same local network. And now, let's wait a few seconds until everything starts up. Once we see that development server is up and listening on the specific port, then it means that we can open this on our browser and have, okay, it should be around this time now. Okay, now that we see that the development server has started, I can go to this port locally. That's the one here. And that gives me the exact same replica of the system that is currently live on the CRIMS website. So I can experiment with the code if I want, see the changes in development mode, or extend the code base, or even try to sign up or verify, and it will work as exactly the same as the ones that we have on the live system. But this is localhost, as you can see. That's the one thing. And the other one that was about the REST framework, as I said, we can expose a specific URL because it takes HTTPS and redirects it. I will open it on incognito. So that's the Swagger API, Open API specification that again gives us this interactive dashboard from which we can interact with APIs. So for example, I can see for this Activate Account API, I can see the model that is bound to this API. It expects an email and a verification code. They are both required fields. And I can also try to execute, make a call to this API. And below, I see the different types of responses that I can get. So if I send that with an example email that doesn't exist, when I execute, I will see that it returned resource not found because this username doesn't exist. So that's that. And we also have the /doc, which is then documentation. So here again, for each of the APIs that are part of a section. So for example, in the account management, we have all these different APIs. I can click on each one and see what types of parameters it expects and what are the possible response status codes and what each status code represent and how I can handle it from that point on. So that's pretty much about the local development. And when we are done, we can just stop the container and then rerun them again, or we can have them running and make changes while we are in development mode. So now I see that everything has stopped. And we are right on time, I think. So if there are any questions, please feel free to let me know.
Thank you, Argyris. Thank you, Iphigenia. You gave us a deep look in the technology stack of CRIMS framework. I think that it is very helpful for ICT specialists that will use and expand our tools. Okay, thank you. Are there any questions for Argyris or Iphigenia? All right, then we can have our coffee break now and come later on at 4 o'clock for the webinar. Thank you very much.
See you in a while.
Thank you.
Thank you. Bye.